Okay, so let's imagine we've got carbon and oxygen. We're going to react it together to make CO2. And now, so we could have millions and millions of atoms of carbon and millions and millions of molecules of oxygen. Um, and then we're going to produce millions and millions of molecules of CO2. The reality is that we're not going to be able to get every single atom of carbon to meet every last molecule of oxygen. There are going to be some that just don't, that won't actually make it. And there are going to be other reasons that we might spill something. Well, in this case, we've got a gas and a solid. So some of the gas might escape, some of the oxygen might escape and not react with the carbon, or some of the resultant product might escape anyway. So for all those reasons and a few more that I probably haven't thought of, we're going to not get 100% yield. Okay, so we've got carbon plus oxygen. Let's say that we've got let's say we've got let's say we've got a whole mole of carbon and a whole mole of oxygen. We should get a whole mole of carbon dioxide, but maybe we don't. Maybe we get 0.7 moles of CO2. Well, if we started with, if we should have got a mole, then we could say therefore we have a 70% yield. Okay. The actual yield could be in grams. The percentage yield would be 70% in that case, and this would be the yield in terms of moles. So that's basically what the yield is all about. Okay, so we need to understand that it's going to relate to atom economy. So we've got so atom economy then is related to percentage yield, but it's more about looking at the reaction as opposed to what did we actually get. You're going to actually use the atom economy along with the percentage yield. So in practice, what would you actually get if you did this experiment, taking into account the amount of carbon monoxide we might lose and so on. What we're doing, this is a process to produce hydrogen. If you wanted to collect hydrogen gas, react methane with steam, and we get hydrogen and carbon monoxide. We don't want the carbon monoxide. It's a waste product or a byproduct, and the hydrogen is the desired product. The reactants are the things that are reacting, the methane and the steam, and this is a desired product and a byproduct. So the atom economy of reaction is a measure of the amount of starting materials that end up as useful products. So we've got these are the starting materials, the methane and the steam, and out of that we're going to get this much hydrogen. Okay. So it's important for sustainable development and for economic reasons to use reactions with high atom economy. So what kind of things are we using to measure this? We're using that will probably be I'm pretty sure it's going to be moles rather than mass. We'll have to see here. Let's have a look. It's AR12 AR. Hang on a second. So this MR, this would be mass in terms of atomic units. Now, in actual fact, it wouldn't make any difference because we're doing mass divided by mass. So the units would cancel out, and we'd get essentially a ratio or a fraction, and then we multiply that by 100, and that turns it into a percentage. So we want to. So let's do this. Let's do this now. It shows us how to do it anyway. But we've got carbon. We've got methane plus steam producing hydrogen and carbon monoxide. It tells us all the atomic masses. The mass number of all of them, right? So methane is going to be 12 plus 4. So methane is 16. Okay, so that's methane. Hydrogen is going to be 2 plus 16. Hang on a second. 2 plus 16. 2 plus 16, 18. Yeah. So the total mass of the reactants is going to be 18 plus 30 plus 60. 16 plus 18, which is 34. That's the total mass, right? So this number up here, that's the 34. Yeah. Okay. And out of this balanced equation, the total mass is going to be, well, it's three lots of this. 3 lots, and hydrogen atom is a hydrogen atom has got a mass number of 1, so hydrogen molecule has got a mass number of 2, and there are 3 of them. So we're going to, this one will amount to 6 atomic mass units. So total, 6. So it's going to be 6 over 34 multiplied by 100. All right. Let's just scroll down to make sure I've not embarrassed myself. There you go. 6 times 34 multiplied by 100, and that gives you an atomic an atom economy of 17.6%. Does that make sense? Yeah. So let's have a go at another question then, using what we've just learned there. So we'll scroll down and look at this question here, and we'll reveal the answer in a moment. So I'll let you read that carefully and have a go at that. And you can use zoom annotate to draw on the board. So in this question here, it says ethanol can be produced by the fermentation of glucose. So ethanol is the thing that we're trying to produce. It says it can be produced, which means we're trying to produce it. So this one here, this is the desired product. And in this case, we've only got one reactant. So what you want to work out is the the mass of the desired product, which is this one here, divided by the total mass of all the reactants, and there's only one reactant. That's that one there. This number here that you've worked out, this is the mass of the reactants. Okay, so the thing is going to be over 46 for a start. That's the amount of the reactants. Okay, we're trying to produce this one here. Now, oh wait, sorry, no, that's the wrong way around. No, sorry, this was the that's the thing that we're trying to produce, isn't it? Sorry, hang on a second. Let me just get the eraser. So I'll tell you what, if I just erase that and then put the line at the bottom. So yeah, so that is the product, that is the desired product. And the thing that the reactant is this one here. So that's going to be 12 times 6 plus 12, 12 times 1, because there's 12 hydrogens, plus 16 times 6. And whatever that's going to be equal to, that's going to be what we're going to that's what we're going to divide 46 by, okay? So we've added up the mass numbers of the products that we're trying to get, and then you've got to remember to multiply it by 2, because there are 2 moles of those being produced. That's written here. And then you divide it by the products, by which we worked out here, 180. 92 divided by 180, then you turn it percentage by multiplying it by 100, 51.1%. Okay.